Hello and welcome to a video on finding an unknown angle using the sine rule. So just have a little recap on the sine rule. We have A over sine A is equal to B over sine B is equal to C over sine C. So we're not working with right angled triangles, we're working with different triangles here. So I'm going to attempt to draw one. Anyone that's seen my videos would know that I'm not particularly good at drawing. It looks a little bit like a right angled one, but it's not meant to be. So this one is given as 94 degrees, and we're going to have a side length of, I've given the game away a little bit already. That's going to be a side length of 11. This one's going to be a side length of 14, and we want to find this angle here. So first things first, we will label the angles and then the side lengths. So let's just call this A, this B, and this C. And we'll label the side lengths as the lowercase of the opposite angle. So in this case, A is equal to 14, B is equal to 11. So we know A, but we don't know B. So the part of the sine rule we will use will be A over sine A is equal to B over sine B. It's by the sine rule. So we will rearrange this a little bit. What we'll do is we're going to flip this upside down, and we're going to say sine B over B is equal to sine A over A. And then what we need to do is eventually we need to isolate B, but we've got to do a few things first. So we're going to say sine B, multiply both sides by that length side B. That will give us B sine A over A. And then that would be sine B is equal to 11 sine 94 degrees over 14. And that is equal to 0.7838 and so on. Again, remember your calculator needs to be set at degrees. We're working with degrees right now. We'll do radians another time. So I'm just going to continue on this page. What we then need to do is we need to have B by itself. So we need to take the inverse sign on the other side. So this will look something like this. So B equals sine inverse, and then that number we just found a second ago, 0.7838 and so on, and that will give us 51.609 degrees. So we're not done here. This would be the acute angle, but we need to make sure that that's the correct one. So all angles of a triangle will add up to 180 degrees. So we can try something else here. So we can have 180 minus this 51.609 and so on. Now that will give us 128.390. Done it again. I like to be as accurate as I can be. So this will be the obtuse. So this will be the acute, and this will be the obtuse angle. However, this may not stand, because if B is equal to 128, then, so if B is equal to 128, call it 128 degrees in this instance, ignore the decimal for the time being, then A plus B is equal to 222 degrees, which can't happen because we're working the triangle with a maximum of 180 degrees across all its angles. So that in that case, this one wouldn't be correct, but this one would be. So we will say that B is 51.6 degrees to 1 decimal place. I hope that makes sense. We just needed to make sure that the first angle we got, the acute angle, was the correct one. Otherwise, we're looking at what the obtuse angle might be, because when we played around with what the obtuse angle would be, A was 94 degrees. We add that to that obtuse angle, and that just doesn't make any mathematical sense. So we're happy with the 51.6 degrees for this angle here. Okay, thanks for watching. Please do like, comment and subscribe. Throw any questions in the comment section and I shall see you in the next video. Cheers.